All right, and we're back. So this is just a video going over some questions from the test review. We got number 25 here. So let's get to it. Oh yeah, there was no number 21. Did you guys catch that? There was no number 21. I don't know what happened there. I don't know where 21 went. I don't know if that was supposed to be a question on there and I took it off at some point. Okay, so number 25, the velocity function in meters per second is given for the particle moving along the line. Find the displacement and then the total distance traveled during the given time interval. All right, so total distance, the displacement, the net change is the integral, right? The net change from starting point to ending point is basically just the integral. Find the displacement. So what I'm looking for in my first part here is just the integral. Is just the integral going from 0 to 6 of, oops, not a good start, is the v of t dt, right? That's going to be the displacement. So let's figure out what that is. So that's the integral from 0 to 6 of t squared plus 2t minus 15 dt, or in other words, the antiderivative. So t to the third over 3 plus 2t squared over 2 minus 15t from 0 to 6. Will you follow me there? So we've got, that evaluates to be 6 to the third over 3 plus, it's just 6 squared, minus 15 times 6. And that would be minus 0, but all of that stuff is, or plugging in 0, but all that stuff is just 0 when I plug it. Why did I write t? Yikes. That's a 6. There we go. All right, so we got 6 to the third divided by 3. Get a 72 plus 6 squared or 36 minus 15 times 6. That gets me 18. So 18 minus 0 is 18 meters. Let me double check my answer here. Yep, 18 meters. That's just displacement though. That's the easy part of it. The hard part of this question is, what's the total distance traveled? Now remember, displacement just gives me the net change. Like right at the end, at 6 seconds, where is it in relation to the starting value? Could it have gone forward? Could it have gone backwards? Yes, that's the issue here. So we have to figure out where it's going forward and where it's going backward. So if my velocity equation is t squared plus 2t minus 15, so v of t is equal to t squared plus 2t minus 15, and I'm going from 0 to 6. I want to know when it's moving backward, because when it's moving backward, I want to take the opposite of that. I want to take the negative of that piece to figure out the total positive distance traveled. All right, so that means I've got to figure out where the zeros of this thing are. T squared plus 2t minus 15 equals 0. Okay, so negative 15 factors a negative 15 that I had to get to positive 2. I don't know why I'm writing that out. I'm so algebra brain. T plus 5, t minus 3, right? So that means my zeros here are t equals negative 5 and t equals positive 3. Does t equal negative 5 matter to us? No, we don't worry about that one, A, because it's a negative time value, and B, because it's not within our domain. It's not within our time frame that we're looking at. I'm only looking at seconds 0 to 6. Is 3 within that range? Yeah. So that's going to be our issue here. Let's figure out, where is my velocity negative? On the left side or on the right side of 3? Well, if I plug in 0, obviously it's going to give me a negative number here. So anything from 0 to 3 is going to be negative. What's anything beyond 3? Well, it's positive, but let's just see. Let's plug in 5. 5 squared plus 2 times 5 minus 15 is a positive number, right? So we know to the left of 3 is negative, to the right of 3 is positive. Okay, and then I'm going to end at 6, right? So what I need to do is I need to take the opposite of the integral from 0 to 3 and just take the integral from 3 to 6 and add those two things together. Here's the notation for that. For 0 to 3, I'm going to take the opposite of v of t dt plus the regular from 3 to 6 of v of t dt. Okay, that's the notation that we're going to use. So let's figure out what they are. All right, again, this was t squared plus 2t minus 15. So negative integral from 0 to 3 of t squared plus 2t minus 15 plus the actual integral from 3 to 6 of t squared plus 2t minus 15. Got my dt's there. Which means I need to take the antiderivative again. We've already done that. So it's negative the t to the third over 3 plus just t squared minus 15t from 0 to 3 plus, and then we've got t to the third over 3 plus t squared minus 15t from 3 to 6. Now the nice thing about the left side here is that I can just plug in 3 because my f of a is 0, right? F of b minus f of a. So that's going to be 0. So I'm just going to plug in 3 to the third divided by 3 plus 3 squared is 9 minus 15 times 3. Negative 27. But I want the opposite of negative 27, right? Because that's 27 meters moved in the negative direction. So I'm changing that to positive to get the total change in distance. And now what we do here is we have to plug in 6 and then actually subtract it by 3. So this becomes the hard part. Well, not really hard part, but adds that extra step. 6 to the third over 3 plus 6 squared minus 15 times 6. And then I'm going to subtract away 3 squared to the third over 3 plus 3 squared minus 15 times 3. Yeah. So let's run that number. All right, 6 to the third over 3 plus 6 squared. We just did this once. Minus 15 times, not divide, times 6. Yeah, wasn't that 18? Yeah, that was 18. So positive 27 plus 18 minus, and now we've got, this is the new number, 3 to the third divided by 3 plus 9 minus 45, right? 3 times 15. Negative 27. I guess because that's true. It is 3 and it's away on the opposite side, so it should be the same because it's a quadratic. Whatever. So minus a negative 27. So my net distance traveled is 27 plus 18 plus 27. 72 meters altogether. So there's an easy part and a hard part to this problem. The hard part is finding the total distance traveled. The easy part is finding the displacement, because the displacement is just the integral. The distance traveled, you have to figure out where it's moving in the negative direction, and then take the opposite of the integral of that, because that's going to give you the integral is just going to give you the distance traveled in the negative direction. You take the opposite of that, find it, turn it positive, and then add it back on to the positive distance traveled. But you got to figure out where that is by finding the zeros of the velocity. Right. That's going to be a lot of work. That's going to be a lot. I'll give you a lot of room there for that one. What other questions do we want to talk about? Yeah. 23. 23. Any other questions on this one? Okay. Let's take a look at 23. Okay, so general indefinite integral is just finding the general antiderivative, right? There are going to be questions that say just find the general antiderivative because that was section 4.9. So there are going to be some questions that look very similar to what we had done in the past as well. All right, so let's take a look here. But what do I mean by that? I mean by that you're going to feel like some of the answers are the same. Because that's truly what it is. like if I just said find the antiderivative of this, you get the exact same answer. Because now we know that the indefinite integral is the same as the antiderivative, the general antiderivative. Just gotta figure out what it is. So don't be afraid of that. Don't be like, I'm doing it wrong. Here's what we would do for this one. Right? I'm gonna reduce down that to try to turn it into like just a polynomial with just powers. And then use the antiderivative rules from that one. All right, so that's really just 4 divided by x to the 1/2 plus 6x over x to the 1/2. And now I'm going to bring up 4x to the negative 1/2 and turn it negative. Plus, now this is 1 minus 1/2, right? So that ends up being 6x to the 1/2. We all see that there? Now we take the antiderivative rules. So we say we want the integral from, well, not from anything, of 4x to the negative 1/2 plus 6x to the positive 1/2 dx. Okay, kick up the power 1 unit. So that's 4x to the positive 1/2 divided by 1/2. And this is going to be plus, I always make this a decimal, 6x to the 1.5 over 1.5. Plus c, right? If I'm asking for the in general indefinite integral, you got to add on that plus constant. All right, so let's figure out what that is. 4 divided by 1/2, that's 8 x to the 1/2 power plus 6 divided by 1.5. Is that 4? 4 times x to the 1.5 power plus c. I mean, I guess if you wanted to manipulate it anymore, you could. I don't really need this if you want to, though. 4x to the 3/2 power. Honestly, I'm okay here. If you wanted to, though, I mean, I guess we could get really fancy with it and do that. Isn't that 4x radical x plus c? If we were getting real fancy with it, because that's 1 and 1/2. Pull out 1, leave 1. I'm teaching that in algebra 2 right now. I guess that's the true answer, but I would accept the 1, 2, 3. Yeah. Question on this one?
Yeah. Can you not combine the AS and the 4?
No, I could if it was the same variable raised to the same power, but they're not raised to the same power. I could multiply them, but I can't. Yeah. Any other questions on this one? Okay, what one did you say?
24.
24. Oh yeah, the trig one. This one is tricky until you figure out that it simplifies. Like this one's like, oh, what's cosine? And you got to do tangent. What? But what is tangent? Sine over cosine. Sine theta over cosine theta. D theta. That's a theta. Whatever. You get the idea. And then what happens? The cosine cancels. So this is integral of sine theta d theta, which is what?
You have to add a C.
Negative cosine plus c. Again, I'm gonna be nice to you. It's only sines and cosines. I'll tell you right now, it's only sines and cosines.
We get that sheet.
No. Sure. It's only sines and cosines that you really need. It's only the career. Yeah.
You like the tangent plus the sine of the cosine to make interaction.
Yeah, you know. Yeah.
So like one's like 19 and 20 where it says sketch the graph. What would you give me like a graph to work with, or are we just gonna freehand it?
Freehand it.
Okay.
Yeah, freehand it. It's gonna be very similar to what was on the quiz.
Okay.
Yeah. What other questions? Yeah.
Go for 18.
Sure. You guys should feel proud of yourselves. Like, look at, like, if you started, if I show this to like the beginning of the year, you guys, you'd be like, what? We know how to do that? Like, it just looks like gibberish. But you guys like understand what this means. Isn't that cool? Like, you guys can read this. Well, most of you can. You should be able to do that. But it's like reading a different language. Like, you know what this means. Like, back like, freshman year if I would have showed you this, you'd have been like, that's just foreign language to me. But now you know what I mean.
I remember when I didn't know what the quadratic formula was.
Right. Like, think about the growth from freshman year U to senior year U. And that's like, you know how to do some pretty hard stuff. All right, so let's get to this. So we want from 1 to 4 of this thing. And again, I'm going to simplify down this thing before I try to actually take the integral of it. All right, so that's x to the 3rd over x to the 4th minus 2x to the 8th over x to the 4th dx, which is 1 to 4 of x to the negative 1 minus 2x to the 4th dx. Okay, now we can take the antiderivative, which means that we say ln of x. Remember, x to the negative 1 is 1 over x, so that's the unique case of ln of x. Minus 2x to the 5th over 5 from 1 to 4. And now we plug in. We plug in 4, and we get ln of 4 minus 2 times 4 to the 5th over 5 minus ln of 1 minus 2 times 1 to the 5th over 5. Which that ends up being like a really small number, but that's okay. So we got ln of 4 minus, nope. ln of 4, close parenthesis, minus 2 times 4 to the 5th, all divided by, I'm going to put this in parentheses. I don't know if I'm going to mess it up, but I'll do it anyway. Insert parentheses. Parentheses. 2 times 4 to the 5th, all divided by 5. Well, no, just close. Negative 408.21. Negative 408.8.21 minus, okay, now we've got ln of 1, close parenthesis, minus 2 times 1 to the 5th. 1 to the 5th is just 1, right? So 2 times 1, or 2 fifths, which is negative 0.4. All right, so we have negative 408.21 minus a negative, I don't know why I did that, 0.4. 407.81. Is that what I got here? Let me just double check. 407.81. Yep. Negative 407.81. Uh-oh. Let's check it.
I think you just forgot his X.
Oh, did I?
Yeah.
What did I write?
You just had 3x squared plus 2 plus c.
Oh, yeah, 2x. Sorry. Yeah, that's wrong. Because if you bring it up, 6x to the 3rd over, or 6x squared over 2, 3x squared plus 2x plus 2. Yep. See, we can do all that fancy stuff, and then you like forget an x. Forget a c. Sorry, I didn't mean to cut you off.
On the one like number 5.
Yes.
When we just 5x, you have to have a c on the end of your answer for that one.
Yes.
Yeah.
And actually a c and a d. You wanted me to do that one?
Oh, no, it's okay.
You know what I mean, though?
Plus cx plus c.
Right, because you're going to create one constant for your first antiderivative, and then take a second different constant for your second antiderivative and put that down.
Okay. So it's just like the one where it gives you like the test of 0 equals, you just don't.
Right, you just don't have that, so you don't put anything in there. You just leave the placeholder of the constant. All right, questions? What else do we need to see? Like my neon. Look at that. I had those in my desk for like forever, and I never used them.
I like
We could write that we would test tomorrow.
I know, I really don't do this, I'm really sorry. Test
Guys, we don't matter.
tomorrow.
And the next day.
Well, it'll still be true tomorrow.
View. Yeah.
Oh, there it is.
I like how.
You got this. You still matter.
The green's not as fine.
I know, I like the orange and the pink.
Can you even see the yellow?
I was gonna say, what is this? Is that yellow?
Yellow.
The yellow,
Oh, yeah. You
yeah, see the yellow and the orange this is orange, right?
Yeah.
See, that looks the same to me.
Can you color
What?
one?
That looks exactly the same. I don't see any difference.
Seriously?
I'm serious.
I see
What do you see,
three
yellow or
different-
orange?
Well, what does anybody see?
Okay.
Like, color is just, you know, perspective
Can you
anyway.
just-
Why is the
I
sky
don't
considered blue? Because it's color.
How can you just-
Are you colorblind?
I just know, like, see, these three look very similar to me. I see this one as a darker shade of these two. But these look identical. I can't tell.
Really? Okay, wait, I don't.
And how did you write yellow and yellow?
When you watch fireworks,
Because we
Because I-
just told them that.
are
because I
all
know.
the fireworks with the gold color?
No, I mean, I can, it's a problem with distinguishing colors in between themselves. Like, that's what, like, truly that red, green color line here is, like, it's
That's what my mother is.
distinguishing colors between the two. Like, certain shades of purple and certain shades of blue look very similar. I can tell, like, one's darker than the other. Like, I can tell that.
Like, you sitting and doing the computer, and he goes, Mom, you want me to put my eggs in purple, but I can't find it.
I'm purple. Yeah, like, this is torture for me. When you go like, oh, what color do you want? It's like, whoa.
That's why you.
Like, a lot of them look the same. That's why I use like the distinct red, the distinct blue. I can't tell the difference between those two. I always know that red is on the left and green is on the right. That's all I know. But they put something in the lights for the street lights so that it's a very distinct change. So I can see street lights, I know that. But if we're pulling up to like a flashing yellow light, I have to ask my wife, is that yellow or red? Because I don't know. Like, because flashing reds are stop signs, but flashing yellows are just caution. So I always have to, have to ask my wife, yellow or red, yellow or red?
What happens if you buy yourself?
If it's a flashing red, there's usually a stop sign there too. I usually just stop.
Like, that's really watching.
Nobody will kill you if you stop at a flashing yellow light.
Right. As long as there's nobody flashing.
Yeah. I mean, it.
Right, exactly. One time I just slowed down and stopped. It's like, what did I just do? Oh, and I was waiting at a light, and I was waiting for it to turn green, and the light changed on the other side, and I was like, oh, it's time to go, and I didn't realize they were getting a green turn arrow, and I didn't realize it, and I just went. And they honked at me, and I was like, I thought somebody was just saying hi, and then I realized like 5 seconds later, I just went through a red light. What is that? Like, look at it. It's like in the middle of our camp too. There's gotta be one of those like,
Did you?
I don't know, not yet, we'll see.
Oh, that's recent.
It was like a week ago.
in your mailbox
in a Right.
couple days.
Right. All right, I'm glad that was all recorded. Are there any other questions on the test review before I let you kind of just go? No? Okay, let me turn off the video and you can just do whatever you need to do.